Hi everyone, this video is about determinants and Cramer's rule, chapter 3, section 4. In this section we will be converting very complicated matrices into a single number. Every square matrix has an associated value called its determinant, denoted by det and the matrix written right beside it, or shown by straight vertical brackets. So we can find determinant of every square matrix. First, we will begin by finding determinant of 2 by 2 matrix. We will start from the simple one. So in order to find determinant of 2 by 2 matrix, all we have to do is take the difference between the numbers written in the main diagonal and subtract off the product of the numbers written in the other diagonal. So this is difference of the products of the diagonals. So let me show you how to do this. First, you will write the determinant as det and the matrix itself, or we will be using straight vertical brackets without writing det, like an absolute value symbol, and put the numbers inside that. So we will find determinant by multiplying matrices on the main diagonal first, a by d, and subtract off the product of the numbers written in the other diagonal, b by c. So order matters. First we will multiply numbers in the main diagonal and subtract of the product of the numbers written in the other diagonal, ad by minus bc. Let me show you an example. Check it out, 1a. It's asking about finding the determinant. So we either write det and the matrix itself, or we can use straight vertical brackets without writing det and write the numbers inside those two brackets and calculate the products of diagonals. Take the differences. So first you multiply the numbers in the main diagonal, which is going to be 0.2 times 5, and subtract off the product of the numbers written in the other diagonal, which are 30 by negative 0.3 multiplied by, okay. Now, when you calculate this, you're gonna get here 1. 0.2 times 5 is 1. And negative by negative makes positive. 30 by 0.3 makes 9. 9 plus 1 is 10. So basically in this topic, we will be finding a single number. Determinant means a single number. So rest of the questions are solved like this. Let's solve a question involving some expressions. Exercise 31, find determinants. The same method. We will be multiplying numbers in the main diagonal first. First of all, let's write this as determinant form: x minus 1, x plus 1, x. I can either put the numbers, the expressions between two straight vertical lines, or I can write det in front of the matrix to represent the determinant. So multiply the numbers on the main diagonal, which are x and x, and subtract off the product of numbers written in the other diagonal, which are x plus 1 times x minus 1. So now this is also easy, but you should be careful about the signs and the distribution. X by x is x squared minus, open bracket, maybe there is a long expression, maybe short, we don't know. So not to confuse, it's better to put the expression on the right in the bracket. So you either do the distribution one by one, or you could remember the difference of perfect squares, like a minus b times a plus b is equal to a squared minus b squared from grade 10. If you remember this expansion, this difference of two perfect squares is expanded as x minus b x plus b. You could also see that this is difference of two perfect squares, x plus 1 x minus 1 is same as x squared minus 1 squared. If you can't remember this, do the distribution in a long way. X by x, x by minus 1 by x, 1 by minus 1, and simplify and stuff. Okay, let's simplify this. It's equal to x squared, distribute minus to the bracket, minus times x squared minus x squared, negative times negative, positive 1. X squares will cancel out, the result becomes 1. See, still we get a single number. So this is how we find determinant of 2 by 2 square matrices. This was the first part of the section. The second part is about Cramer's rule. Cramer's rule. By using Cramer's rule, we could solve the system of equations, which you studied in grade 10, solving system of equations by two variables. So first thing we need to do is writing the equations in standard form. I mean, x's and y's are on one side of equation, constants are on the other side. And then to find x or y for both, we should use the coefficient determinant at the bottom. Determinant coefficient. By coefficient matrix I mean, take the coefficients of x's and y's, write it inside the matrix. So the coefficient of x, a1, coefficient of b, b1 for the first row, for the second row, a2, b2. So we should write the coefficients first. We use these coefficients as a determinant in denominator to find x and y. In numerator, in order, we should write the coefficients of x's and y's. But when you find x, instead of using coefficient of x's, we will use the constants. For the coefficient of x's, we're going to replace it by the constant. For y, in place of coefficient of y's, we're going to write the constants. Coefficient of x's comes first and then constants. In x, constants come first and the coefficient of y's. So this is how you find x and y. And you also know that a system sometimes have no solution, sometimes only one solution, sometimes infinitely many solutions. And if denominator is not 0, you could say that there is one solution, one unique solution. If denominator is 0 and neither x or y's numerator is 0, then there is no solution, because remember, number over 0 is undefined, so there will be no solution. Or you could have 0 in denominator and 0 in one of the numerators. In either x's numerator or y's numerator you have 0. In this case you have 0 over 0, which is different than number over 0. So this means you have infinitely many solutions. And classifying the system, remember from chapter 2 section 5, if there is no solution, the system is inconsistent. If there is infinitely many solution, system is consistent. There is one solution, system is also consistent. So those are the things you should know to solve questions. Let's take a look at the first question. Use Cramer's rule to solve each system. So let's find the coefficient matrix first. The coefficient matrix, the coefficient of x's, write it as one column, 1, 2. Coefficients of y's, negative 1, negative 1, write this as another column. This is your coefficient matrix. And find the determinant of coefficient matrix. This is your denominator. This is the first thing we need to do after writing the equations in standard form. So multiply numbers in the main diagonal, 1 by negative 1, minus, multiply numbers in the other diagonal, 2 by negative 2, negative 2. Negative, negative makes positive, 2 minus 1, 1. So 1 is your determinant of coefficient matrix. So now let's figure out what x is. X is equal to, apply the rule. Rule says take determinant of coefficient, instead of coefficient of x's, we will write the constants, which are 3, negative 1. And for the coefficient of y's, you write negative 1, negative 1. All over determinant of the coefficient matrix, which is 1. So find determinant here. 3 by negative 1, negative 3, minus negative 1, negative 1, positive 1, which gives you negative 4. So the value of x is negative 4. What about the value of y? The value of y, similarly, you have 1 in denominator. In numerator, write coefficient of x's as a column, 1, 2. You just replace the coefficient of y's by the constants, 3, negative 1. And take the determinant, 1 by negative 1, negative 1, minus 3 by 2, 6 over 1, which is negative 7. So we got the solution. We know x, we know y. Your solution is, as a point, negative 4 comma negative 7. So this is how we solve a system. You learned different methods in grade 10, like elimination, substitution. This is another way. Let's try B. Find determinant of the coefficient matrix first. Write the coefficient. Oh, but there is a problem here. My system is not written in standard form. So first I should write it into standard form. So in the second equation, we have x and y on the left, number on the right. But for my first equation, we don't have the same situation. Bring x to the other side, negative 3x. Y is already there. And I also should bring number to the right. So now it is written in standard form. My second equation is already written in standard form. Now I can start solving the question. Find determinant of coefficient matrix, coefficients of x's and y's, negative 3, 3 as one column, and 1, negative 1 as another column. Calculate the determinant, negative 3 by negative 1, 3, minus 3 by 1, 3, which is 0. So my denominator becomes 0 for both x and y. So remember, if my denominator is 0, there are two possibilities. If neither numerator determinant is 0, then there will be no solution. If at least one numerator of determinant is 0, there will be infinitely many. Let's see what situation we have here. So for x is equal to, our denominator is 0. For y, our denominator is 0 as well. So let's calculate them one by one. For x, in place of the coefficient of x's, we will write the constants, 2, 7, as one column. For the coefficient of y's, we will write 1 and negative 1. Now compute the determinant, 2 by negative 2, negative 2, minus 7 by 1, 7, over 0, negative 9 over 0, number over 0, undefined. Let's see if we have 0 over 0 situation here or number over 0. In order to find y, write coefficients of x's first. Negative 3, 3. In place of coefficient of y's, we will write the constants, 2 and 7. Compute the determinant. Negative 3 by 7, negative 21, minus 3 by 2, 6 over 0. Negative 27 over 0. So in both, we have number over 0 condition. Neither of them has 0 over 0 condition. So they're undefined. So we will basically say there is no solution.